3 here, we're going through two other types of distribution here. We've got our geometric and Poisson distribution. So for the first one here, we have that you want to decide that you're going to roll this die. So it's a standard 6-sided die, and you want to roll a 5. And we want to find the probability that the first 5 that you roll is on either the second or the third try. So first of all, you have to try and decide what type of distribution this is. So in this case, since you're going until you get to the first success, or in this case, you're going until you get to this second or the third try here, what that means is that those are going to be your x values in this case for your probabilities. So here, in other words, we'll have probability of 2 for the first try, or the probability of 3 using the equation for the geometric distribution. And here, if we're talking about rolling a 5, you'd have a probability of 1 out of 6, or 1/6 for that. So then the probability of a failure would be 5/6. It'd be everything else. So here in this case, then we'd have 5/6. So that would represent that the first try was a failure, that you did not get a 5. And then the second one is a success if you got the first 5 on the second roll. So if we multiply those together here, we get 5 out of 36, or 5/36. Or we could also round that here as a decimal, and we get about 0.139. And then we can do a similar thing for this other one. If the first 5 is rolled on the third try, what that means is that the first and second try were failures. So we got something other than a 5. So once again, the probability of failure here is 5/6. Remember, once again, to find a failure, you do 1 minus the probability of success. In this case, there were 2 failures first. So we do the 5/6 to the second power times 1/6 for that third try being the success. So in this case, if we multiply that out, we get 25 out of 216. Or as a decimal here, that'd be about 0.116. And then here, since it said we wanted the second or the third try to get the final answer here, we want to go through and add these probabilities together. So whenever we do that, you get either 55 out of 216 as a fraction, or you could approximate it as a decimal here, be about 0.255. Normally for our probabilities, if we're rounding them, we normally go at about 3 decimal places, especially if the probabilities end up being small. So this first one, like I said, this one was an example of a geometric distribution. So I'm going to abbreviate here, geometric there, just as a reminder, that was the distribution being used for example 1 there. For example 2, it's worded a little bit differently. It says we want to have that the mean of free throw shots, so the average here of someone getting a free throw shot for this basketball player is 5. And we have that the probability that in any given game this player will make 3 free throw shots is the probability we're trying to find. So here then the x value, the number of free throws that we want this player to make, is 3. And in this case, the type of distribution we're dealing with, since we're talking about the average or the mean number of throws here, which is 5, means that we're dealing with a Poisson distribution. Normally, if you're given some sort of information about an average for these type of problems, you're dealing with the Poisson distribution. So here, whenever we're plugging this in, for our formula, we have E, which this symbol E really represents the number 2.718, and then there's a whole bunch of other digits here too. It's kind of like the symbol pi, how you can round it to be 3.14. E could be rounded to 2.718 if you're going to round it. But in general, you should be able to put those into your calculators. If you're not sure how to enter it, you can certainly ask in class. So what we have here is we have e to the negative, and then we have the mean. And then times your mean to the x power. In this case, x was 3. We wanted 3 free throw shots all over x factorial. Again, this formula is in your book, but once again, it's also written out this way. Remember this symbol here that looks kind of like a cursive U? This symbol is for your population mean. So that little cursive U there is for your population mean. So you have that, and then you have your mean to the x power all over x factorial was the formula here, where x is that number that's inside the parentheses that you're trying to find the probability of. So x was how many values? Other symbol here, the one that looks like a cursive U, is your mean or your average there. So if we go through and plug it in for our values here, we get about 0.140 for this one. So that would be what we'd expect for the probability for this player to get 3 free throw shots in the game. Exactly 3 of them. Make sure if you have questions on anything, you can always ask during class as well.